other components that calcium works with in the body. So the first thing they'll probably tell you is reduce calcium in your diet. And then if that doesn't work, they'll go with the hormone treatments for those kidney stones. So pathology. When we talk about problems, we usually talk about it from the PTH side of things because that's the one that usually gets a little conquered. But again, if we have a rise in PTH, we should end up with the rise of calcitonin to bring the calcium level back down. If we have a drop in PTH, we should have a corresponding movement with that calcitonin. They tend to balance each other and mirror each other to keep calcium levels at the right point. But if the parathyroid hormone goes off the rails, that's when we tend to have those health concerns. So hypersecretion, too much PTH, which causes too much calcium in your blood, you're going to have otitis fibrosis cystica. So what happens is we just suck it out of the bones and put it into the bloodstream. And when we decalcify those bones, of course, that's going to make the bones weaker. We're going to end up with pockets of soft tissue surrounded by bony tissue. And being soft tissue, it's more likely to be damaged because of stresses and so forth that the skeleton is put under. So that leads to the bone softening. That leads to a lot of fractures. Similar to what Mr. Glass had in that movie series. This could also lead to central nervous system function problems because as we increase calcium in the blood, more calcium means more calcium coming into the neurons, so they release more neurotransmitters, which overstimulates anybody the neurotransmitters are talking to, including each other. It causes nausea and vomiting, and that's because the calcium levels get so high in the blood it becomes toxic. So we learned that, throughout, eat too much of a good thing, no matter how great it is, can be fatal. Too much water will kill you. Too much oxygen will kill you. Too much calcium can cause fatality. So here you're having the nausea and vomiting because the medulla is picking up that calcium level is so much that it's toxic, it's poisoning you. And eventually it's going to cause death of that individual, usually due to those neurological problems. Hyposecretion, not enough PTH, you get tetany. So if we don't have enough PTH, that means the blood calcium drops too low for the system. And that's going to cause issues with both the muscles and the nervous. With the nervous tissue, it causes depolarization without the proper stimulus, without the proper levels of calcium coming in and the releasing of the right amount of neurotransmitters. We can have spontaneous depolarization as those neurons try to hoard the calcium, so they accidentally release a little much. We can have issues with muscle twitching and muscle spasm. So we learned that name. If spasm is a uncontrollable abnormal muscle contraction due to a chemical imbalance. In this case, calcium imbalance there. This is usually caused because the muscle tries to hoard the calcium inside instead of leaking it. And anytime you try to hoard something, it can cause problems, obviously. We always look at the toilet paper hoarding issues of 2020. I know that it's now scarred a generation, okay? Other people are like, oh my gosh, we had the World War I, we had the World War II. Our generation we ran out of toilet paper. It was tragic. Things have changed, man. So spasms, you get too many spasms, you end up with convulsions, which are just really big spasms. You can get respiratory paralysis, especially if the convulsions and spasms are occurring in the diaphragm. And of course, if you can't breathe, you can't live, and it's fatal. Okay, so you do have to have just the right amount of calcium, not too much or not too little. So you can see why, if you do have to have thyroid removal, they want to make sure you can balance your calcium before you leave the hospital, because too much or too little will be a fatality. And it could actually be a very fast fatality, depending on the amounts of calciums that build up in the system. So that patient has to be balanced properly, either medically or their body figures it out before you're able to be checked out of the hospital. And again, these two guys, parathyroid hormone and calcitonin, are antagonists, opposing forces. Okay, so if one goes up, the other will go up to counter. One goes down, the other one's going to go down to counter. So they should balance each other so we have the right levels of calcium to function. There it is, bless you, balancing. So here we've had our disturbance in the force. We get too much calcium in the blood. Maybe you're eating a cheeseburger with your glass of milk. So the thyroid gland releases calcitonin that says pee out calcium, store it up in the bones, drops us back down. Maybe we got a little bit too excited about peeing out calcium or too excited about storing up in the bones. So the parathyroid hormone is going to release in response to the falling calcium. So it's going to say release it from the bone, reabsorb it from the digestive system or from the urinary system to bring us back up. And they're always constantly tag teaming each other depending on the body needs. What was the last time you ate? What did you eat? Is your bones needing to be remodeled? Did you break a bone? That kind of scenario. All right, moving on to the adrenal glands. So the adrenal glands are little glands that sit on top of the kidneys, kind of like little kidney hats. They kind of look like chunks of fat. And at first they thought they were until they removed them and it messed up people's bodies. They're like, oh, wait a minute, that's not all fat stuff. So when we look at the adrenal glands, like many of our body organs, they're going to be set up again like those peanut M&Ms. They're going to have a thin capsule on the outside to keep the organ intact. They're going to have a cortex, and this core of the organ is going to be called the medulla, just like a peanut M&M has a thin candy coating chocolate and a core peanut. So when we look at it, the capsule always just contains the organ, keeps it separate from the rest of the gang, and makes sure everything stays together and does its job. The cortex and the medulla, the tissues look very different. In the case of the adrenal gland, each layer makes its own hormones, just like chocolate has a different flavor than peanuts do. So you'll have hormones coming from the adrenal cortex. You'll have different hormones coming from the adrenal medulla. Now, collectively, the hormones coming from the adrenal cortex are steroid hormones. So this is where, unfortunately, due to cultural references, a lot of people always assume steroids are, this testosterone that you're not supposed to get. Steroids are a classificational hormone that just has a fat chaser, okay? It has a steroid as its component. Steroid hormones include the obvious one, testosterone, that we've all heard about, but it also includes estrogen and progesterone. Those are steroid-based. All of your thyroid hormones are somewhat related to steroid hormones. These guys, so when someone gets a steroid shot because they are too snotty and they have an sinus infection, that steroid shot isn't a shot of testosterone. It's a shot of glucocorticoids to stop your snot from acting up. So steroid is just a classification, a type of hormone. When we look at hormones, we're not getting detailed into the different types of hormones because chemistry. Yeah. But there's protein-based hormones and there's steroid or fat-based hormones and thyroid hormones, which are a little weird because of the way they're built. Okay. Now, with the steroid hormone, they can be problematic because that steroid gives them kind of like a backstage pass. They can go through the cell membrane, they can go through the nuclear envelope without anybody checking them. Okay? Just like that backstage pass can get you anywhere backstage. Protein hormones have to have a door letting them in. They have to bind, open the receptor, open the door, come into the cell. So you can limit how the body responds to protein hormones. With steroid hormones, with that backdoor activity, there's no stopping them. So you can't stop a steroid hormone from changing the functionality of that cell. And when a steroid hormone changes it, it changes it at the DNA function level. So it's not just changing what the cell is doing, it's changing how the DNA is responding. And that's why they can be so problematic and tricky to deal with, because there's no way to stop them from coming into the cell because of the way they're built. And they do affect the functionality of the cell at the DNA level, not just at the organelle level or anything like that, which makes them a little bit trickier to manage and deal with. Now, because they are steroid hormones that come from the adrenal cortex, oftentimes you'll hear them called corticosteroids because adrenal cortex and steroid-based hormones. So where they're from and what they're made out of. So the adrenal cortex has three major categories of hormones. Our first ones are glucocorticoids. Again, corticoids because it is a cortex hormone, a steroid hormone, and glucose because it does something with your glucose. It does something with sugar. So as we mentioned last week, insulin is not the only sugar messing up hormone that we have in our body. So even though that's the one that gets all the glory on the commercials, there's usually 4 different hormones that could really mess up your sugar levels. We looked at human growth hormone last week. This is another one that can really mess up. You can go into a diabetic coma if you have too much glucocorticoids, even though they're not related to diabetes at all. They're not related to insulin at all. So our types of glucocorticoids, we have cortisol. It also goes by its drug name hydrocortisone. This is something that you can actually buy over the counter, right? When you have a red, itchy bug bite or an itchy rash because of, I don't know, poison ivy, or you touch something weird. Don't touch weird things. But when you have that red, itchy rash, you do hydrocortisone on it. That gets rid of the red, itchy rash. It suppresses the immune responses. So this one, again, can be used topically, and most of us probably already have it in our medicine cabinet because, bug bite season is a very long season in Texas. Okay. The most abundant, again, is that cortisol. 95% of the activity of glucocorticoids is due to cortisol. We also have corticosteroid and cortisone. Again, we've heard these names before, probably because of, creams that help reduce red, itchy rashes and so forth. Their target are body cells. They're going to help the body to respond to stresses. And that stresses might often be times a pathogen or an irritant or something along those lines. So they regulate metabolism and resistance to stresses. So the things that they do, they're going to promote metabolism to make ATP available. Because when you're fighting an infection, you require a lot of energy to fight infection, just like you have to have a lot of money to fight a battle or a war. So you need to make that, capital available so you can buy weapons. Same thing here. We're making that capital available by getting us that energy, that ATP. It is going to increase protein catabolism, so the breaking down of protein so we can use that if we need to as a fuel source, mainly muscle fibers. This is why people who are chronically sick tend to have little skinny arms and legs. You don't see chronically sick people working out at the gym and being built like Arnold Schwarzenegger. It's because you eat yourself to survive, unfortunately. Gluconeogenesis, again, fun big word when we break it down. Gluco means sugar. Neo means new. So Neo was the new guy in the Matrix, right?
Yeah.
And Trinity kept all three of them working together, and Morpheus enabled everyone to learn how to change their shape. Look, their names meant something.
Mm-hmm.
I know. Big things back in the day. And then Genesis. What does Genesis mean? Origin, the making of, right? Genesis is the first book of the Bible where everything was made. So gluconeogenesis is sugar new making, the making of new sugar. So making sugar from a non-sugar precursor. So we can convert lactic acid into sugar. We can change amino acids into sugar. And this is why we break down proteins. So we can turn those proteins, those amino acids into sugars. And sugar can fuel the fight. Okay, because sugar is the easiest way to make energy for cells. That added glucose, again, is needed to combat stress. And you can see why if you have a spike of glucocorticoids, it can make your sugar go off the rails because this one makes lots of sugar available. And if you don't need that sugar to run for your life, it just kind of sits around causing high blood sugar problems. It's also going to make vessels more sensitive to vasoconstrictors. That means anything that will constrict a blood vessel, we're going to be that much more susceptible, which is going to raise blood pressure. If you are stressed and you need to mobilize defenses and get that sugar to cells so you can run for your life, having constricted blood vessels is a good thing because you can get the material to the location as quick as possible because your blood pressure is higher. Now, if your stress happens to be me, you don't need to run from me. All this is just going to cause you to have high blood pressure problems. And this is why we see people who have stress issues, stressful jobs, have high blood pressure because of these glucocorticoids floating around. Yes, ma'am.
How does that have to do with, like, how people, when they get stressed out, get bad acne? Is that from any of these?
That's because your oil glands are going to increase activities to try to protect your skin from the stresses you're dealing with. And if you have excessive oil, that can lead to acne issues. Because your body hates you and wants to remind you, guess what, pimple bitch? No, it hates you. It's just your job, the body's job to do that. Okay. Anti-inflammatory compounds. Again, this is why we see it as the drug form. So if you have too much snot and you've got a sinus infection, they'll give you a steroid shot. So it causes you to not respond. It basically says, sit down, shut up, and take it. So you don't make as much mucus. And if you don't make as much mucus, your sinus infection can go away and gets rid of a lot of the snotty material that's going on. This is why when you get that steroid shot, they also couple it with your antibiotics, right? They're going to say, sit down, Army, don't respond, don't make mucus. And while you're not responding, we'll give you a drug to kill the bacteria that's fighting it off. That's why you have to have both of them at the same time. A steroid shot alone won't fix your sinus infection. It'll help you not be so snotty, but by suppressing your immune system, that allowed that bacteria to flourish. So that's why it always has to be coupled with the antibiotics because they're telling your army to stand down. So you have to replace your army. Okay? Just like it's like, you guys sit here and don't fight. I'm going to hire somebody else to do that. Okay, so that's why they're always coupled with each other. And how they're able to help us with anti-inflammatory processes. One, it's going to reduce mast cells and histamine. So the basophils won't be able to release histamines, which gets rid of your red, itchy, irritated, watery eyes, or red, itchy, irritated nose, or red, itchy rash. It's telling all your basophils to stop screaming. Right? Stop being so crazy. It is going to stabilize lysosomal membranes, thus depressing phagocyte activity. So it's going to go to your neutrophils and your eosinophils and tell them, you can't kill anything right now. I have neutralized. I put a safety on your gun and now you can't fire. So it's going to depress all of the phils. So neutrophils won't do their job, eosinophils won't do their job, and basophils won't do their job. So again, if you have a sinus infection, that's great because it's going to stand down so you don't make so much mucus. But if you're trying to fight off an infection, then that can be a problem. So that's why it's always coupled with another medication. So it's going to take out all the phils. Now, it won't affect lysosomes because lysosomes, lymphocytes, because lymphocytes don't eat. They just kill and walk away. They're very violent. Okay, so drop the mic kind of cells. So it's not going to affect the lymphocyte activity, but it will affect all of the phil guys. And to a degree, it can also affect monocytes because monocytes are eaters as well.
Is there a word to describe a cell that kills? Because you said
just killers.
Phagocytotic is eaters.
Yep.
So there's just
killers.
Okay.
Yeah, homicidal violent cells. I don't think they've come up with a nice way to say kills you, like the eat you cells. But just killers. Okay. So all of this, depressing all those white blood cells, is going to depress your immune system. Okay, so this is why we put it on things when we want our immune system to calm down, so the red itchy goes away. This is also one of the reasons why they give this to transplant recipients, because unless you have an identical twin, and if you have an identical twin, awesome, you've got a bag of spare parts because they're genetically you. You also have somebody you can blame in case of a homicide, right? Yeah, you do. In case you watch enough crime shows, you and your identical twin have the exact same DNA, so they can't tell the difference between your DNA and your identical twin's DNA. So if you both have, you could be each other's alibi and still have gotten away with murder because prove who did it. I don't know. No reason for that. Isn't that crazy?
That is crazy.
Yeah, so fun about identical twins, which means you won't reject their organs because they're genetically you. Now, unfortunately, if you don't have an identical twin and you have to get an organ from somebody, it's not genetically your organ, so your body wants to kill things that aren't you. So whenever somebody has a transplant, even if they can match it as close as humanly possible, it's never going to be 100% match. So they have to suppress your immune system for the rest of your life. So you don't reject the organ that you've been given. And this is why people who have had transplants, again, can't take certain vaccines, have to be very careful. A lot of times they'll go to the point of saying you shouldn't have carpet in your house because carpet can gather bacteria and stuff, and that makes you sicker. So you should get rid of all those soft surfaces, stuff like that. You have to be very, very careful from that point on, because those immunosuppressants are good enough so you don't kill the liver they just gave you. But unfortunately, that does make you weaker. So more susceptible to colds and flus and everything like that. So you can't get all the same kind of ability to fight off infections when you're suppressed. Hypersecretion, too much glucocorticoids, you get what we call Cushing's syndrome. So you have this rounded moon-shaped face, very full, very kind of fat face, and little bitty spindly arms because you're eating your own muscle, you're catabolizing your proteins, and the best source of protein is muscle, and our most muscular structures are arms and legs. So you tend to lose a lot of that. So the body tends to stay looking normal or slightly swollen because of the change in fluids and so forth. Yes, ma'am.
This is more common in women, right?
So little spindly legs, moon-shaped face, kind of squishy in the middle. This is why a lot of times you'll hear people say if they're stressed out a lot, they gain weight. Cortisol, by catabolizing protein, if you get rid of your protein, protein is your bigger calorie burner when you look at muscles. So if you eat your muscles to survive, you're actually depleting your ability to burn calories. So you tend to gain weight quite quickly. So when people have spikes in cortisol, they may have a corresponding gain in weight. And it's, again, not protein-based weight. It's going to be usually fat-based weight because we're shifting from utilizing